Hey everybody, it's Mrs. Casil here. We talked about energy today, and here are a few more notes to add to your notebook. So first, after our demo today, you have a foldable glued in your notebook with these 5 major types of energy. We're going to add our notes underneath each tab. Be sure to add a doodle on the front of each tab with an example that represents that form of energy to you. So let's just get started. The first form of energy we're going to talk about is mechanical energy. We've done this already, but here's a better definition for you to work from. It's a sum of kinetic energy and potential energy. It's that total energy we've been talking about. If you add all the kinetic energy together with all of the potential energies, that is your total mechanical energy. Now, this is the energy an object has because it's moving or because it can move. And sometimes an object is doing both at once. It's already moving and it can move more. So work is done on an object to make this happen. So there's lots of ways that work, that energy in action, can appear. Mechanical energy can result in the change of an object's shape, the change in an object's position, and the change in an object's motion. All of these are really important to consider and will be part of our lab tomorrow. Second form of energy we're going to talk about is chemical energy. So this is potential energy only. It's stored energy. It's in the bonds between atoms that make up molecules and compounds. It's released during chemical reactions. Until then, it stays stored. That energy doesn't come out. It's not used. It's not made into actual energy until that reaction takes place. So when that happens, a chemical reaction, as you saw today, can make all sorts of interesting things occur. And usually that stored chemical energy, that potential energy, transforms into new interesting forms of energy. It can change into thermal energy and cause a change in the temperature, either up or down, of a substance. It can change the motion of a material. That's mechanical energy. Or it can actually change the compounds that are present in the chemical reaction after it's taken place. This is new chemical potential energy. New energy is stored in those bonds. If we add up the change in temperature, the thermal energy that might be released or absorbed during a chemical reaction, if we add to that the motion, the mechanical energy of the parts, and add to it the new chemical potential energy after a reaction, it'll be equal to the total potential energy we started with. You saw that happen today, plus a little bit of fire. Nuclear energy. This is another type of energy that's potential energy only. Stored in the nucleus of atoms. It has to do with the forces that actually hold the nucleus, the protons and the neutrons, together in an atom. Usually, we release this by splitting the nucleus of a heavy atom, such as uranium or plutonium. This is how we make bombs, and this is how we make nuclear energy. So there's some pros and cons here that we'll talk about later. Now, this is a huge amount of energy. There's a reason why, instead of just lighting things on fire, we try to find sources of energy that are as powerful as nuclear energy. Here's an example. If you take 1 kilogram of wood and extract all the energy that is stored in the chemical bonds that make that wood, you could power a light bulb for 1.2 days. Okay, reasonable, right? 182 years is how long 1 kilogram of uranium could power the same light bulb. It's a lot more energy. Now, there's some dangers involved in accessing nuclear energy, and we'll talk about those later too. Fourth form of energy, electromagnetic energy. So this one, there's some interesting parts here. It's energy that results from moving electrons. That's what an electrical circuit is. Or It's the energy that comes from static charges on surfaces. Example, scraping your socks across the carpet and then poking your lab partner in the ear. Other examples, though, are lightning, where we have static charges that build up. There can be a potential electrical energy there that then turns into an actual electric energy change. It can be from magnetic fields or electric fields. For example, this is how an electromagnet works. By using a moving electrical circuit, the movement of electrons, we're able to create a magnetic field that then can do work, can make changes to metal materials that are attracted to magnets. This is what magnets do, and this is how we generate electricity, is by taking advantage of these interacting magnetic or electric fields. Or electromagnetic energy is also what's happening when radiation, such as light, visible or invisible, travels across our universe. In this case, no particles are moving. This is energy that's traveling as pure energy as electromagnetic waves, whether those are radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-rays, or gamma rays. Last one, and this is what we will use to look at in our lab tomorrow, thermal energy. So this is heat energy. It's a really important and tricky one to understand. This is where a lot of people are getting stuck thinking about frictional energy. Thermal energy is another name for heat energy. Now at the atomic level, all matter is vibrating. It's moving. If you think about what that means, motion, the energy something has because it is moving, that's mechanical energy. That's kinetic energy. Matter has that all the time. When there's more vibration, there's more motion. When there's more motion, there's more energy, just like something bigger that you speed up and make move faster. And if there's more energy, there's more heat. These are all the same way of describing the amount of thermal energy that matter might have. So we measure that motion, we measure that amount of energy by measuring the temperature, sticking a thermometer in something. Now, this is why thermal energy is really important and why we'll look at what it can do tomorrow. Usually thermal energy is lost energy. Now, we use the word lost not meaning it's destroyed, but it's changed into a new form. Thermal energy, you can't retransform it into something useful. If you drop a bouncy ball, it's going to fall. Gravity will move it towards the ground. Its position will change because of the gravitational potential energy it had because of where it was before you let go. You light something on fire so that lots of heat is released, lots of thermal energy radiates out. It transfers into the motion of the molecules of air around that thing that's burning. We can't just squeeze that warm air back together and reclaim that energy to reuse it again. You can pick up your bouncy ball and drop it again just by moving it from the surface of our floor back up to the same height. We can reclaim that energy. We can turn it back into gravitational potential energy. But we can't do that usually with heat. So, there we go.